Hi there. In this video we'll be repairing this ineo external hard drive enclosure. The fault with it is mostly it does not power on anymore, and I think this is to blame. So let's get to it. Again, dual hard drive enclosure. It has a kind of weird connector for the power supply, and it's actually a dual voltage, as you can see here, 12 and 5 volt, which kind of makes sense because these are big hard drives inside and they take 12 volt and 5 volt. So the power supply gives directly the required voltage. Well, this thingy normally it has a LED right here. I'm going to get a cable to quickly connect to it and just show you that it doesn't do absolutely anything anymore. And my plan initially was to search for one of these supplies. Well, I cannot find a reliable one outside of China, and I'm not going to I don't trust one of those to be working for a long time, as this one also didn't work for a really long time. As you can see, so power on off, no LED comes on. This is blown basically. Another chance was to, I don't know, have one 5 volt and one 12 volt more reliable from known brands power supplies and just use this cable, but kind of bulky. But first I might actually crack this up just to have a look inside and see what burnt in here. And obviously if I go with a 12 volt standard power supply, I will also replace this connector right here. I don't need a dual type of this really weird shape. So yeah, but before opening this up, let's take a quick look at today's video sponsor, PCBWay website. And here we are on PCBWay.com, link will be in the video description. They are right about now celebrating 11 years of unstoppable progress. And congrats PCBWay for this. You can enter yourself this event right here, and the rules are just below. And overall, PCBWay can help you with building PCBs, CNC 3D printing. They can also do assembly for you. They can also do PCB design. But the easiest way to see everything that they can do is to go at product and capabilities and see absolutely everything they have in here. So thank you very much PCBWay for sponsoring this video, and let's get back to our project. You cannot really crack it up again to make it still be decent by the way it's done. You don't have a clear side which is which to get something underneath it, and you can see it's all coming apart. I'm just going to hammer the hell out of it just to see what's inside. So if doing anything like this, be warned, the capacitors could still be charged in here. Don't see any sign of stuff being blown up in here, so whatever it's gone, it's a small thing, could be even that thing right there. So yeah, oh no, right there, do you see it? That has blown to smithereens. No interest in me repairing this thing. We have here the colors, I have everything that I need. I will unsolder the wires. In case I want to ever reuse this cable, I can. But I'm going to open that thing and take a good look inside of it and see if I can do what I plan to do. And it was actually easy to see because this was blown also, so yeah. Okay, perfect. And now I think we might have some screws in this area, but I don't know if we need to do anything with those because everything else is at the back of the unit. So I think that's where we need to actually do some stuff and see how much space I have under that PCB right there. Close this right back up. and open the 4 screws right here. No easy way. Let's pull on this area. Hope I don't bend it. It's coming out and it's out. And also I was thinking now, I hope that power supply didn't also fry the internals. And in case it fried the internals, I hope it didn't also fry my hard drives. That would actually suck if it fried my hard drives. I could power them on in something else, so to check that. Okay, so I said I need to replace this. This is gonna be interesting. Yeah, I need to take this board off. How much space I have internally right here? There's a bit of space right in this area. Not sure how much you can see. Normally here it could have some connectors, some network connector and firewire or something like that from the shape of them. I think I can occupy that with a power supply, so I'm going to get 12 volt from here, get it in here somewhere. The 12 volt can also be directly connected in where it needs to be on the PCB, and the 5 volt could be generated here and brought back in here. And a while later, some parts have arrived. This is the charger itself, decent weight to it. Not a brand name, so maybe I should have gone for a known brand. But anyway, it seems, unless it has a bit of metal, cheeky metal in there, not doing anything, just to add weight, seems fine in weight terms. 5 amps, simple connector, nothing fancy. I should have lots of those into which I can plug this in to use a cable for it. And in here, 12 volt to 5 volt converters, 3 amp capable. Yeah, this one, the PCB is not broken properly to the score mark, but anyway, it doesn't actually matter. So yeah, basically I will connect this thingy, give it 12 volts, then take 5 volts out of it and go from there. Removed all screws holding the board in. I will just put them aside. At this point in time, what we have here, so we have the switch for the fan speed. Don't care about that one. It's a really simple fan controller with, I think, from what I can see here, so it's just a resistor. That's all the controlling it actually does. We don't care about that. Let me undo this particular cable right here. Okay, so we are left with the PCB, which is still somewhat glued in here. This connector is glued in here. They didn't want to risk it coming apart. Yeah, it's not coming out, so I'm going to leave it there. We can deal with it, no issues whatsoever. Anyway, now what I need to get out of there is this particular connector. Yeah, these pins were really stuck. I barely managed to pull this, which had 2 of them at the same time. Barely managed it and really pulled on it. So getting the whole connector out, no go. No idea why they did it like this. Doesn't make sense. We are not allowed to do it like this at work, for example, but yeah, they did it anyway. So now let me clean this up. We are lucky we have this diagram right here. So that means these 2 are ground, those 2 are 12 volt, and those 2 are 5 volt. And it's exactly the same right here. So those right there, ground, 12 volt, 5 volt. And 12 volt and 5 volt both are going through this switch. So 5 volt coming here and going here and into the regulator, 12 volt coming here and going here and through a capacitor, and then who knows where it's actually going in the rest of the PCB. But yeah, okay, kind of clear. Now let me find a good connector and find a way to solder it. Found 2 connectors that work, and I decided I'm going to use this one. I don't need anything as fancy as this fellow is, and this, I think it's a bit more rugged, or at least I think it is. But anyway, I have a way of making it fit a bit easier than this fellow by the shape of it. So let me see. Made a bit of progress, used a 2.5 millimeter drill, made a hole through that, right to the other side. So that's the positive. Cleaned a bit of the solder mask around, so solder can attach to the copper, and basically positive will be going through that hole, negative will be ready right next to it, so I can solder it right there with a tiny wire. And yeah, okay, everything should work. And I think we are ready. So let me try and explain what I did here. So we have the ground going from here into the PCB and through the black wire from the other side. It's also coming in here to the 5 volt module. Let's call it regulator by the end of the day. Taking 12 volt and making 5 out of it. Also, I took the 12 volt, which actually comes here, and then when you flip the switch goes in here, took it so it's through the switch, so this thing will not run all day long, only when this is actually on, like the rest of the electronics also do. So through the switch, this is on, 5 volt, again I put it in here, so it's also switched right here. Probably it wasn't necessary because 12 volt is already switched, so there was no voltage, but I wanted them somehow to come on exactly at the same time, but still probably it will not happen because this needs to be on first and then this is starting up. There will be a tiny delay between them, but hopefully not enough to bother any electronics in here. And yeah, in theory that should be it. I think I will actually test this thing just to see if it powers on without a hard drive. This seems to be fairly stable, but I will also put some hot glue around it when the case is closed, just to make sure that everything stays in place, or maybe even before the case is closed. Also some hot glue around this thing, but even if this would touch directly the PCB, would somehow scratch it through the double-sided tape, they are both actually grounds. And I didn't take a negative from here because it's basically exactly same thing. Not sure if this will be happy or not in this configuration. It's a bit weird, but I think it should work. So nothing else to do than try to power it on. If it doesn't, well, I will buy a different type of unit, pop my hard drives in it and go for it, because I did not use any sort of RAID. I never use RAID in stuff that could actually break, because I kind of like my data, and especially hardware RAID. Nope, not risking it. So yeah, let me set this to 0 and plug in here 12 volt and see what we get. And I think I'm ready. Hopefully I did everything right. In case I didn't, well, some smoke will come out. In theory now the fan should start and maybe we see some light from the LEDs inside. Okay-ish. We do have some light from that 12 volt module. So maybe that thing blowing up blew up this thing also. Oh, that would be a bad day, wouldn't it? But yeah, then I would just buy a different type of unit and be done with it. I'm going to try and poke around a little bit, but honestly, it should be working already, shouldn't it? Tried something else to connect this directly so this is always on, just in case they need to be exactly at the same time 12 and 5 volts, but I don't think so, because the electronics most likely runs on this 3.3 volts. But hard drive needs 3.3, I think, 5 and 12 at least. 5 and 12 for sure, 3.3 I don't know if it really needs it, but probably. Didn't help at all. And then I realized I had all kind of weird readings. I actually didn't properly have a ground on this thing, and actually that thing right there is not connected to anything. So the plug that was here before wasn't grounded, its external ground wasn't connected. So to have negative in here, ground whatever, actually negative, to have it in here, I need to go from that wire to those two tiny contacts right there. So yeah, interesting. Anyway, I can do that easily, and this will switch again here, so it's switched and will not be always on. Hopefully it works. Let's see, work or smoke? Work. Okay, the little fellow is working. Doesn't have hard drives in it, obviously. I'm not going to connect my good drives. I'm going to plug in 2 older laptop drives. If it fries them, I don't really care that much. I don't have any data on them. But if those work normally, we are good to go. And everything is fine. So the PCB is covered in hot glue. Also put Kapton tape in here. Hot glue even in here, so that PCB isn't moving. If it can melt this whole hot glue plus the double-sided tape to break loose, there are worse things happening. Modified the hole a little bit for the connector to come out. Hot glue all around it. It's not moving anywhere. Wires are not moving. These are not moving. This is an extremely bad connector. This is why they had some hot glue in there. They knew what they were dealing with, because wires started to pop out of it. It's only for LEDs, so it still works even if I completely disconnect this, but still annoying. Anyway, fan is again plugged in place. This has enough room in here. It's only the thickness of this. Actually no, because it enters inside of it. No, nothing. So it will not, nothing will push on it at all. And yeah, that's about it. So in theory, at this point I can just pop it in here, make sure the wires dry at least to... Oh, actually no, my bad. I only put 2 screws on it. So yeah, I will put all the screws back and pop it in there, put 4 more screws, and it should work. And now we have a simple 12 volt connector, negative outside, positive inside, for everything, which is awesome. This is what they should have done from the start, but they cut some corners. Maybe they got some dual supplies really cheaply, no clue. Absolutely no issues whatsoever internally. You would expect those wires to not allow the hard drive to go all the way in. They actually do. I think they were somewhat like that even before, so yeah. But our wires, camera please focus, are not in the way of anything. So yep, we are good to go. Everything seems perfectly fine, even in the top corner right there. We can power this on. I realized I will not bother with laptop hard drives. I have 4 terabyte Ironwolf NAS drive that I'm actually not using, and this thing will draw more than any laptop hard drive for sure. So I'm going to plug this thing in. I don't have any useful data on it at the moment, so yeah, I will not necessarily be happy if I fry it by any means, that's for sure, but neither will I pour my eyes out in case this drive has any issues. So yeah, power on from the adapter itself. Now this is on, everything is fine, and let's see, do we have a spinning drive? That to me sounds like a spinning drive. Awesome. Now I'm going to wait around it and watch some YouTube videos, feel if anything seems to be overheating in any way. Then I will actually plug the proper drives in, and I think we are good to go. This has been running for about 15 minutes. No heat whatsoever in the 5-volt area. Fan doing its thing, no heat anywhere. Even this is not heating up. This was heating again only by being plugged into the socket. Off position, this was a bit hot. Not extremely hot, but a bit hot, just by running by itself. This is running a hard drive, not doing anything obviously, but running a hard drive, and it's completely cool to the touch. So this is much better. Yes, with 2 hard drives probably it will heat up a bit. At least you will know it's working, but no. But this was a stupid device. And again, I can go on a bigger 12 volt if I need to. Internally, again, the 5-volt module, it's actually 3 amp and we needed 2 amp. So it's 50% more powerful than what we need. Should handle it. This is again 1 amp more powerful than what we needed in total. So yeah. Actually, if you calculate in volts, the other one had in volts, no, in watts. This one had 34 watts. This actually has 12 times 5, so it has 60 watts. Much more than this one, because this had 5-volt 2 amp, which gives 10 watts and plus 24, 34. This does it all at 12. And then internally, again, the 5-volt, yeah, doing just fine. Let me put other drives in and hope that computer sees them and they work just fine. Let's see. First, startup with 2 drives. Do we hear startup noises or something goes wrong? Second one spinning up. Yep. 2 distinctive searches. Both drives are running. We did it. Now, you can ask me in the comments how this performs over time. Obviously, I will copy from it, copy to it, use it exactly as I was doing before. Hopefully, with even better results than before. Again, no heating from this. That's my hope. But anyway, if it heats up, much easier to improve it now than it was before. It's in its normal working position, and now I'm hitting both drives, copying data. Let's see, anything will heat up or not. Okay, so copied a lot of data, nothing is heating up. So this, the power brick, the 5-volt inside here, I'm trying to feel any heat, almost nothing. So yeah, this seems to be much more stable in current form than it ever was with its original power supply, at least until now. But yeah, that's about it for this video, so feel free to ask in the comments how this fares over the years. Check out my other videos, subscribe, and see you in the next one. Bye.